Hello students, I am Rupesh and I will be teaching you arithmetic progression for class 10. Right, so today I am going to teach you arithmetic progression for class 10. What is arithmetic progression? Before proceeding to arithmetic progression, I would like to tell you some other sequences. For example, like there is a progression of odd numbers. You can say the progression of odd numbers. So list like 1, 3, 5, 7 and so on. So this is a sequence or this is a progression having odd numbers in it, right? Another, you can take another sort of progression like the squares of all natural numbers. Squares of natural numbers. So what are squares of natural number? Like starting from 1, then 1 square will be 1 and 2 square will be 4, then 3 square will be 9, 4 square will be 16 and so on. So this is also a sort of progression, this is also a sort of progression. In the similar way, there is a sequence or a progression called as the arithmetic progression. Now what is special about arithmetic progression? What is arithmetic progression? So let's see what is arithmetic progression. In arithmetic progression, if suppose there are terms like 2, 4, 6, 8 and so on, arithmetic progression is a progression or a sequence in which the difference between the consecutive terms is same, right? The difference between the consecutive terms is same. For example, 4 minus 2 will give you 2 and 6 minus 4 is also going to give you 2 and 8 minus 6 is also going to give you 2. So this type of progression where the difference between the consecutive term is same is called as arithmetic progression. This is a form of arithmetic progression. You can take some other arithmetic progression, for example 3, 7, 11, 15 and so on. So this is, let's check whether this is the arithmetic progression or not. So 7 minus 3 is going to give you 4, 11 minus 7 is going to give you 4, 15 minus 11 is going to give you 4. I suppose the difference between the consecutive term is coming same, so therefore this is an arithmetic progression. This is also sort of arithmetic progression. Is it clear? Now suppose if I take terms this way, 15, 11, 7, 3 and so on. So can anyone in the class tell me whether it's an arithmetic progression? Yes, it's also an arithmetic progression. Let's see what difference the consecutive terms are holding. 11 minus 15. Now you're going to subtract 15 from 11. Okay, so you are going to select any term and you have to subtract the preceding term from that term, right? So 11 minus 15 will give you minus 4. Again 7 minus 11 is going to give you minus 4 and 3 minus 7 is also going to give you minus 4. So this type of progression where the difference between the consecutive terms is going to remain the same is called an arithmetic progression. So what is the condition? What is the condition required for a progression or a sequence to be called as arithmetic progression or to be an arithmetic progression? So what is that condition? So let's see. Suppose there are 3 terms, say A, B and C. For these 3 terms to be called as an arithmetic progression or have to be arithmetic progression, what is the condition required? The condition is B minus A should be equal to C minus B. What it will be? B minus A is equal to C minus B. Now it will be like, you can bring this B this side. So it will be like B plus B is equal to C plus A, or you can write 2B is equal to A plus C. So this is the condition for any sequence to be an arithmetic progression. Are you getting my words? Are you getting it? That to be a sequence, the condition required for a sequence to be an arithmetic progression is 2B is equal to A plus C if the terms are A, B and C. If you let the terms to be A, B and C, or you can simply say B minus A should be equal to C minus B. So this is the condition required for a progression to be an arithmetic progression. Is it clear? Now see. Now I will be taking again the same example I have told you earlier. The same arithmetic progression we are taking for reference, like that was 3, 7, 11, 15 and so on, right? So this is an arithmetic progression. Here this first term of an arithmetic progression will be denoted with small letter with small letter a. This this first term is going to be denoted by small letter a, right? And the difference which the consecutive terms is holding, that is called as the common difference, and will be denoted by small letter d. Is it clear? Here the common difference is 4, and the first term is, this is called as the first term, and the first term is 3. So a is equal to 3 and common difference d is equal to 4. Got the point? In arithmetic progression, the first term of the arithmetic progression will be known as a, and the common difference will be known as d. That will be represented by d, and this first term will be represented by small a. Is it clear? Now, if I ask you what will be the fifth term of this arithmetic progression, now we are considering this arithmetic progression. If I ask you what will be the fifth term of this arithmetic progression, that is quite simple. You are going to add 4 to it and you will get the next term, that is the fifth term, that is 19. If I ask you what is the next term, again you are going to add 4 to this, 19, and you will be getting what? 23. So this is how you are going to get the next term. But if I ask you what will be the 201st term of this progression, what will be the 201st term, or if I simply say a small letter, I will take like 51st term, what will be the 51st term of this arithmetic progression? Now it becomes difficult for us to find out this term. So let us find out what is the formula for finding out this 51st term or any term of the arithmetic progression. So let us find out the formula. So how we are going to find out the formula? Let's see. See, dear students, what I told you is that arithmetic progression is a sequence where the difference between the consecutive terms is same. Where the difference between the consecutive terms is same, and that difference between the consecutive terms is given by a small letter d, and the first term of the arithmetic progression is given by letter a. So suppose I take an arithmetic progression where the first term is a, or you can simply write this way, like first term is a and the common difference is d. I am taking an arithmetic progression where the first term is a and the common difference is d. So what will be the first term of the arithmetic progression? Obviously a, I told you that just now. The second term of the arithmetic progression will be a plus d. Obviously the common difference is d, so the first term is a, then the second term will be a plus d, right? The next term will be a plus d. Why we have to add d to the next term so that we can get the next term. We have to add d to the given term so that we can get the next term. So it will be a plus d plus d. Now the next term will be a plus d plus d plus d. Again we are going to add d to this term and we will get the next term, and so on. Or one more term I am taking, a plus d plus d plus d plus d, and so on. Is it clear? Now this can be written simply, this can be written as a plus d, a plus 2d, a plus 3d, a plus 4d, and so on. Now just have a look at this sequence. You just thoroughly look at this sequence, and what you are going to find is that this is the first term where the first term is a plus 0d. What is the first term? A plus 0d. There are no d added to a. Okay, and in the second term there is only 1d added to a. So the second term is having 1d added to a. Now the third term is having 2d's added to a, that is a plus 2d. Now the fourth term is having 3d's added to a, and the fifth term is having 4d's added to a. What is that? Again I am going to tell you that the first term is having 0d's added to a, the second term is having 1d added to a, the third term is having 2d's added to a, the fourth term is having 3d's added to a, fifth term is having 4d's. The first term is having 0d's, the second term is having 1d, the third term is having 2d's added to it, the fourth term is having 3d's added to it, the fifth term is having 4d's added to it. Am I clear in here or not? So if you have to find out the nth term of this AP, how many d's will be added to a? Then there will be n minus 1, one less d will be added to a. So the nth term of this arithmetic progression is going to have n minus 1 d's added to it. Here see, this first term is having 0 d's, that is 1 less d. Second term is having 1 d, that is 1 less d. Third term is having 2 d's, that is 1 less d. Fourth term is having 3 d's, that is 1 less d. Fifth term is having 4 d's, that is 1 less d. Then nth term is going to have n minus 1 d's added to a. So this will be the formula for finding out the nth term of the arithmetic progression. Is it clear, students? I suppose you must have got this formula, that is the formula for finding out the nth term of any AP. Is it clear? Now we will be moving back. I hope this formula is understood by all. All of you just copy this formula somewhere so that you can understand, and derivation I have shown you, right? So moving on to the moving back to the previous question I asked you a little back. What is that question? That was, you have to find the 51st term of the arithmetic progression, which was having terms 3, 7, 11, 15 and so on, right? So this was the arithmetic progression which was having terms. These are the terms of the arithmetic progression. Then the first term was 3 here. The common difference was 4 here, and you have to find out the 51st term of this progression. What do you have to find out? The 51st term. You have to find out the 51st term. So now you know the formula, that is to find out the nth term of AP, that arithmetic progression, you have to apply the formula a plus n minus 1 into d. Means if the term is 51st term, then there will be 50 d's added to a. So it will be like a51 will be a plus 51 minus 1 into d. So it will be a plus 50 d. Is it clear? Now the 51st term will be a is what? 3 plus 50 into common difference is how much? That is 4. Now this will be 5 4s are 20, that is 200 plus 3, that is equal to a51, and that is 203. Is it clear? I suppose this is very easy. Now you must have got how to apply the formula of arithmetic progression. Now let's take few of the examples so that this becomes clear to you. I should say more clear to you. Now let's take few examples. So one of the example I am taking is the nth term of the sequence is given by 2n minus 3. The nth term of some arithmetic progression is given by 2n minus 3. So nth term is represented by 2n minus 3. There is arithmetic progression where the nth term is given by 2n minus 3. Find the 15th term. You have to find out the 15th term. A15 you have to find. Is it clear? So this is nth term. Like that means A1, the first term, will be equal to 2 into 1 minus 3. That is, you have to replace this value that is representing nth term, that is 2 times n minus 3. So first term will be A1, that will be 2 into 1 minus 3. A2 will be 2 into, replace this n by 2 now, 2 into 2 minus 3. What will be the third term? 2 into 3 minus 3. Is it clear? So A15 will be 2 into 15 minus 3. Is it clear? So this will be like 30 minus 3, that is 27. So this is how you can find out. Sometimes the nth term of AP will be represented by a linear equation, and in that linear equation you will be finding, and that linear equation will be in n, and you have to replace n by that number of term, like 15th term you have to find, then you have to replace n by 15 so that you can get the 15th term of the AP. Is it clear, students? Let's move on to another example. Now there is an example which says you have to check whether root 3, 2 root 3 and 3 root 3, whether this is an AP or not. You have to check whether this is an AP arithmetic progression or not. So how are you going to check whether this is an arithmetic progression or not? That is very simple. You have to take the second term, then subtract the first term from it, take the third term and subtract the second term from it. So, and if the difference, then you will get the common difference. If the difference is going to remain the same in the consecutive terms, then it is an AP, otherwise it is not an AP. If the difference between the consecutive terms is going to remain the same, then it is an AP, otherwise it's not an AP. So this will be 2 root 3 minus root 3, then this will be equal to root 3, because this can be written as 1 root 3, so 2 root 3 minus 1 root 3 will be root 3. Hai, it's very simple now. This is 3 root 3 minus 2 root 3, so this will be equal to how much? That is again root 3. So the difference between the consecutive term is same, therefore it's an AP. Is it clear? I suppose the things are clear to you now, right? Taking another example, let's take another example. Which term of the AP 1, 4, 7, 10, which term of the AP 1, 4, 7, 10 is 52? Which term of AP 1, 4, 7, 10 is 52. So here the AP, the arithmetic progression is 1, 4, 7, 10 and so on. This is the arithmetic progression given to us, and this will be the first term. So the first term of the AP is going to be 1. The common difference of the AP is going to be 3. Alright, and it is asking which term of this AP will be 52. So we don't know which term it is. Which term of this arithmetic progression is going to be 52. So I am going to mark it as the nth term. I don't know what will be the value of n, where this term is going to come, at what place this term is going to be coming. So I am going to take this term to come at nth place, right? So the nth term of this AP will be, let the nth term of the AP be 52. So we are taking 52 as the nth term. So nth term is represented by a plus n minus 1 into b, right? And the nth term now we have taken is 52. The first term of this AP was 1 plus n minus 1. We don't know at which number this term is going to come. So n we don't know. We have to find out the value of n. So take it as n right now, and common difference was 3. Now let's solve this. So this will be 51, because 1 is going to come this side and will get subtracted. So 52 minus 1 will be 51, and minus 1 into 3, right? So we're going to divide this. So it will go how many times? 1 time, 2, 7 times. So it will be like 17 is equal to n minus 1, and n is equal to 18. So this 52 is going to be the 18th term of the given sequence. This 52 is going to be the 18th term of the given sequence. Is it clear? So I hope you are getting the sums. Now let's take another sum, one more example. So that the concept is more clear to you guys. So let's take one more example, dear students. Determine the arithmetic progression whose third term is 5 and the seventh term is 9. Whose third term is 5. I am directly writing in mathematical form that the third term is 5. A3 represent the third term. Is it clear? So the third term is 5. Sometimes in some books the nth term is represented by Tn also. So don't get worried or get tense about this. What is that Tn? Tn is equal to n plus that is a plus n minus 1 into d. It is only the representation of the nth term. Similarly, an also represents the same thing, that is a plus n minus 1 into d. This represents the nth term and this also represents, sometimes this also represents the nth term. So it's your choice that you have to write it as tn or an, right? So now I'm writing it in mathematical form that a3 is 5. That means that the third term of any arithmetic progression is 5 and the seventh term of the arithmetic progression is what? And the arithmetic progression was given to us as 9. The seventh term is 9. Now we have to find out, what we have to find out? We have to find out the AP, determine the arithmetic progression. We have to determine the arithmetic progression. So a3 is 5. What does this mean? This means a plus 2d is equal to 5. How I got this? I have just applied the formula for nth term. That is a3 will have a plus 2d's added to it. That will be a plus 2d is equal to 5. This will be the first equation. And from here you are going to get the second equation, that is a plus 6d is equal to 9. Is it clear? So that will be the second equation. Now you are going to solve them simultaneously, like a plus 6d is equal to 9 and a plus 2d is equal to 5. Just subtract the equations. Just subtract the equations and you will get the answer. A will get cancelled out. This will be like 4d is equal to 4 and d is equal to 1. So you got the common difference from here. You can substitute the value of common difference in the equation 2 or equation 1 as you like, and you will get the first term as well. So a plus 6 into 1 is equal to 9. Then a is equal to 9 minus 6, that is a is equal to 3. Now you got the first term, you got the common difference, you will get the AP as well. Now the AP is going to be, the first term is 3, the common difference is 1, then the next term will be 4, then the next term will be 5, then the next term will be 6 and so on. Is that clear? So I hope this lecture was clear to you and you must have now understood how to find out the nth term of any AP and also how to check whether the given sequence is an arithmetic progression. Thank you, my dear students. Be at home, be safe, and all the best.